let's look at this particular problem. X1 plus X2, this is going to be a 3 variable system that you're trying to solve here. First thing I want to do is I want to create the the augmented matrix. Do you remember how to make an augmented matrix? Augmented matrix is made of two things, made of the coefficient matrix and the constant matrix, right? So what are the coefficients for the first row? Can anybody tell me that, please? Say it again, please. Coefficients for the first row, what are they? Thank you. 1, 1, 1. Constant is 3. Second row, 2, 3, 7. Here is 0. Last row, 1, 3, -2, 17. Yeah, okay with how I got there, right? You remember doing all this stuff? Now, the goal is to get ones along the diagonals and zeros everywhere else, right? Look at your first row. Do you have a 1 on the diagonal? Yes or no? Yes, we do. So let's try to get zeros beneath it now, right? Y'all got that? Let's get a 0 beneath it. So how do I get a 0 in row 2? Somebody remind me, what do I do? How do I get that 0 in row 2? I want a 0 to sit right here. What should I do? Multiply the first row by what number? -2. Good, a few people that remember that. So we're going to multiply in this first step. The first thing we're going to do is we're going to multiply that first row by -2. So the first one I'm not going to touch. The first one's going to stay as 1, 1, 1, 3. But now I'm going to multiply row 2 by -2 R1 plus R2. So -2 R1 plus R2. So remember, we're multiplying everything in this first row by -2. And we're going to add it to R2. So what's -2? So -2 times 1 is a -2, right? Plus 2, what's that? That's your 0 right there. -2 times 1 is a -2 plus 3, +1. -2 times 1 is a -2 plus 7, 5. And then -2 times 3, or times 3, is a -6, plus 0 is going to be a -6. Second row has a 0 where it's supposed to go. It also has what along the diagonal, by the way? It has a 1, which is nice for us. Does everybody see that? Now, we need a 0 to go beneath here, right? We need a 0 in this spot right here. Again, using row 1, how do I get a 0? Using row 1, how do I get a 0 to go in this spot right here? What can I do? Just do what? I got to talk louder this morning. Thank you. So or just instead of doing -1, we could just subtract the rows, right? If I subtract row 1 from row 3, what's going to happen? That's what you're doing. You're making a negative, by the way, though. If I do row 1 minus row 3, this minus means that you're turning everything down. You're just flipping all the signs down here, by the way. Do y'all see that? So what we're going to do is, what's 1 minus 1? 0. That's why I'm just subtracting. Do you understand that? They both have 1s on that spot. So I just want to make this one a 0. So I'm going to do 1 minus this 1 right here. That gives me a 0. Some of y'all are looking at this like, man, what? We are taking this steps at a time, by the way. I want you to realize that, all right? I am looking at individual elements to try to get what I want. Right now, when I started this, I wanted a 0 right here. I didn't care about anything else in this particular problem except getting that 0 right there. Do you understand that? Same thing here. I don't care about anything else except getting a 0 right here. Do you understand that? So when you look at this, look at it as small parts. It's going to take a few steps to get there, but we need to do this to get us there. So we need a 0 right there. So that means I'm going to do 1 minus this 3 right here. What's 1 minus 3? -2. This next one says I need to do 1 minus a -2. So what's 1 minus a -2? What's minus a minus? That makes it a what? A positive. So that's really 1 plus 2 that you're adding. What's 1 plus 2? +3. 1 plus 2 is +3. Why is it a plus? 2 reasons. You can do it like this. 1 minus -2. Minus a minus makes it a plus, right? This negative also means to do what to every sign down here, by the way? It means to flip it. You're really flipping all signs down here, by the way. That's what you're really doing. So this is really going to be a positive 2 sitting here. You could flip sign and add if you want to as well. So I could have did negative R3 plus R1 was another way to do this. But right now, here's what we get. We're going to do this 3 minus 17. What's that? What's 3 minus 17? Negative 14, right? All right, so let's stop and look and make sure we have what we want. Do we have a 1 on the first diagonal? Do we have a 0 underneath that 1? So we're good so far, right? What has to happen next? We need a 1 where? On the second diagonal right here, right? Do we have that 1 there? So what do we need beneath it? So we need to make this into a 0. How do I get that to a 0 using the second row? What do I need to multiply it by? A 2. And then what I'm going to do, add the 2 rows. All right? Multiply this by a 2 and then add those 2 rows up. The reason I'm adding is because, look, what's 0 plus 0? That's not going to change that. It's going to keep my zeros in the same spot. All right? So I'm going to multiply. Doing it again. I'm not even going to look at the first row. I'm going to leave the first row like it is, all right? Eventually I'll get there, but right now I'm just going to leave it like it is. Second row, not going to touch it either. Third row, I'm going to multiply that row by, right, it'll be 2R2. Why am I doing 2R2? I'm going to multiply this one. I want to multiply this one by what number? By 2. And I'm going to add it to what? R3 to get that 0 there. So again, look what happens. 2R2. What is 2 times 0? 0. What's 0 plus 0? So I keep a 0 in that row. Keep a 0 in that element, which is what I want. Next, what is 2 times 1? 2. What is 2 plus a negative 2? 0, which is what I want here. Everybody got that? What is 2 times 5? What's 2 times 5? 10. What is 10 plus 3? 13. You okay with that? That is 13. Next step. What is 2 times a negative 6? What is negative 12 plus a negative 14? Negative 26. This works out extremely nicely right here, right? So look what I have now. I have a 1 here, a 1 here. What's beneath every one of those 1s? What do I need to sit right here? A 1 on the diagonal again. Does everybody understand that? How do I make this into a 1? We wanted zeros, we had to add rows, right? We want zeros, you have to add and subtract rows. Everybody got that? If you want this to be a 1, you have to divide rows. You have to divide by. What am I going to divide this by to make it a 1? A 13. I'm going to divide the entire third row by 13, as a matter of fact. Because when I divide this by 13, what's 13 divided by 13? Puts a 1 right here. What's 0 divided by 13? What's 0 divided by 13? It's not changing it. Does everybody understand that? That's what we're doing now, right? If you want to get 1s, you typically do division or multiplication. Everybody understand that? If you want to get zeros, you need to add or subtract. So we go from there. First 2 rows do not change. So I have 1, 1, 1, 3. Then I have 0, 1, 5, negative 6. And now I'm going to do R3. Technically, you multiply by 113. You can divide by 13 if you want to say it like that too. But that's the same process. R3 times 113. So 113 times 0 is 0. 113 times another 0 is 0. 113, 1 over 13 times 13 is 1. 1 over 13 times the negative 26. What's that? So what's negative 26 divided by 13? Negative 2. And that worked out extremely well. What do I have on my diagonals now? 1s, right? What's beneath the 1s? Zeros. What do I need to have above the 1s? zeros. And these zeros above the ones as well. Does everybody understand that? So how do I get a 1 right here? How do I get a 1 right here? This time I'm sorry, not a 1. How do I get a 0? My fault. You're right. This is a 0. How do I get a 0 right here? Remember, I want a 0, so what should I do? Multiply or add? Try it again. Zeros means we need to add some things, all right? We need to add something to get here. Well, look what I can do. If I do 5 times negative 5 times R3 plus this, right? Anytime I do something multiplied by a 0, what am I going to get? A 0, right? So watch what happens when I do this. 1, 1, 1. I'm not going to touch that bottom row. The bottom row is going to say 0, 0, 1, negative 2. I'm going to multiply the second row by negative 5 R3. Negative 5 R3, and I'm going to add R2 to it. I'm going to add R2 to it. So watch what happens. What is negative 5 times 0? And I'm going to add 0. I'm going to add the row 2 to it. So what's 0 plus 0? 0. Doesn't change it. What's negative 5 times another 0? 0. I'm going to add the row 2 to it. What's 0 plus 1? Which is, I want to keep the 1 on the diagonal. Y'all got that? Now, what is negative 5 times a positive 1? Negative 5. What's negative 5 plus this 5 right here? Do you understand what I'm saying? When you're trying to get zeros, you're always trying to add things. You understand that? When you're trying to get ones, you're trying to do what? The multiply, divide. Everybody got that? So now that I have that 0 there, last part, what is negative 5 times a negative 2? What's negative 5 times a negative 2? Positive 10. What is positive 10 plus a negative 6? Positive 4. Look what we have now. Zeros right here, right? 0, 0, and we have 1 on the diagonal of a 0 up here. How do I get what do I need a 0 at now? I need a 0 right here. So what should I do to get that 0 right there? Get a 0 first. How do I get the 0 right here? Oh, you're right. You said it right. Multiply by. I'm going to multiply by what? Multiply this row by negative 1 and add it to this one right here, right? And I can see this because I know when I multiply by negative 1, that's not going to change this one at all. Do you understand that? Because you have a 0 sitting here. So what's 0 times anything? And when I add it to this, I'm going to get what's still up here? A 1. But when I multiply this one by negative 1, that makes this a what? A negative 1. And then I add it here, I'm getting a 0. So watch. And again, I'm taking it step by step. I want y'all to realize that. I'm not going like, when I looked at it, when you start it off, it looks daunting. But you realize that you're just going rows to rows. You realize that you're going by each element to get zeros and ones. So this is not changing. This is also not changing. That top row, I'm going to multiply it by, first thing I'm going to do is negative R2 plus R1. Negative R2 plus R1. So basically it's saying multiply by making everything negative on this row, right? And then adding it to R1. So what's a negative times 0? That's just 0. And 0 plus 1 is 1. What's a negative times 1? Well, that's negative 1. So this is a negative times 1, or negative times 1 plus 1 is what? 0. What's a negative times 0? 0, right? Plus 1 is a 1. What's a negative times 4? Negative 4 plus 3. Negative 1. There we go. Last thing, what do I need now? I need a 0 sitting up here, right? How do I get that 0 there? Can y'all see it? Do you see this 1 right here? It has to cancel out with that 1 up there. So what should I do? Do negative R3 plus R1. And that finishes this entire process. So again, middle row does not change. Bottom row does not change. Top row, we're going to multiply the top row by negative R3, right? And then we're going to add what to it? R1. When I go after zeros, I have to do some kind of adding, all right? So here, negative 0 right here, plus a 1 is what? 1. Negative 0 plus a 0, 0. Negative 1, remember you're looking at a negative R3, so negative 1 plus a 1, 0. Last part. This becomes the opposite. Negative 2 is actually a what? Positive 2 plus a negative 1, positive 1. Here's your solution. X1 equals 1. X2 equals 4. X3 equals negative 2. Or the point, you have the point 1, 4, negative 2. Now, that problem was a little complicated maybe, but it's really not if you look at zeros and ones. I got that? I think on your test, I'm not going to give you a 3 by 3. I think I'll give you a 2 by 2 until you do it like that. But let's shorten this process a little bit. Go for it. To shorten it for me, I wouldn't like I honestly wouldn't try to get it to. This is what we call this is the identity matrix, and the identity matrix is nice because it spits out all the values to you, right? Honestly, when we got to this step right here, we could have back substituted everything and found the rest of it. And what I mean by that is we could have said that we know that x3 is equal to what? From here, I know that x3 is equal to negative 2. How do I know that? Because I have this 1, I have a row of zeros and a 1 right there, and it equals negative 2, right? Now, then what does that tell me? Look at the next row. The next row says what? X1 plus 5x3 equals negative 6. So what do I know? Well, I know, not x1, x2. x2 plus 5, what is x3? Negative 2. That equals negative 6, right? So what's 5 times negative 2? So that is x2 minus 10 is equal to a negative 6. What can I do next? Solve for x2, right? Add 10 to both sides. What do I get there? x2 equals 4. So look what I've gotten now, which if you come back down here, look what x2 is. x2 is 4, by the way, right? And now what do I know from the same matrix? What do I see up here? Well, now I see that x1 plus x2 plus x3 is equal to 3, right? Well, what is x2? 4. What is x3? Negative 2. That equals 3. So what's 4 minus 2? So this is x1 plus 2 is equal to 3. How do I solve for x1? Subtract 2. So I get x1 equal to what? And look at my solutions. There they go. They are 1, 4, and negative 2. Now, which way was easier? The way that I just did it was easy. Back substituting was a lot easier. Back substituting only works though when you get one of your elements. You have to have one of the actual values. Y'all got that? So if you get this value down here, you can always go back and back substitute. Unless I tell you I want the identity matrix. This is called the identity matrix right here. Anytime you have all zeros and ones, it's called the identity. Technically, this is what we call row reduced. Anytime you have a diagonal full of ones like this and zeros underneath it, that's called row reduced. And once you get to row reduced, you can back substitute. All right. Yeah, it is. It's like because there's so many steps to it. It's like that's what I'm trying to tell y'all. When you look at this, don't look at it as I'm doing all these different steps. Look at it as this is what I have to do. Let me do this first. All right. I need to get a zero here. How do I get the zero here? I need to get a one here. How do I get the one here? And when I say that, I mean when you're thinking about zeros, when I think about a zero, I need to add or subtract something. When I think about ones, I need to divide something. All right. So your test will be. I'll finish these notes next week. Right. This packet is the last packet I have in the set. So once I finish these notes, your test will be an online test this time, all right? It'll be an online test. And you'll have from Saturday until April 10th, we don't have class. I just don't want to come. No, it's my daughter's birthday is April 9th. My wife's birthday is April 10th. So I'm just, I'm gonna be broke, sad, and a whole bunch of things. So I'm just not gonna come. So April 10th, we don't have class, all right? Do what? Yeah. So that's what this is. That's how I'm paying for it. So yeah, so April 10th, no class. That means I'm gonna make the test due. If I give y'all 2 weeks, are y'all gonna take the entire 2 weeks to do it? I don't want to do it. I don't want people to be sitting there talking about like I don't want people to be like April. Like if I give y'all, I want to give y'all from so to open up April 2nd or April 3rd, right? 3rd is Saturday, right? Yeah, the day I'll see y'all is 3rd. So on the 3rd, I don't want to give y'all all the way till the 10th. I'm not gonna be here, so that means it would be doing the 17th. Y'all got that? But that's 2 weeks. Some of y'all, if y'all get 2 weeks, y'all gonna take it on this. Nah, you got it's a time test. It's one sitting. It's 2.5 hours. 2.5 hour test. One sitting. Um, multiple choice. I think it'll be on probably Pearson. It'll probably be on my math lab. Probably be on my math lab. All right. So this one will look more like your homework too. By the way, this test will look more like your homework. So I'll decide on how long I'm gonna leave it open, but it'll open up April 3rd for sure, right? Opens up April 3rd. We'll talk about how long we'll leave it open next week. All right. So, um, we've already discussed what a matrix is, right? And now we're going to talk about these different operations that you can do with these matrices, all right? And basically, it's addition and subtraction, and it's multiplication, scalar multiplication, all right? So, matrix addition or subtraction can be performed only with matrices that have these same dimensions. They have to be the same dimensions. What do I mean by dimensions? They have to have the exact same rows and the exact same columns. Exact same rows, all right? Exact same columns. And to add that, we add each element to its corresponding element. So for instance, in this one right here, if I want to add these two matrices, first off, the first thing I'm always going to do with any matrix is I'm going to check its dimensions. Remember, we rows, so this has 2 rows by 2 columns. So this is a 2 by 2 matrix. This one, 2 rows by 2 columns. So it's a 2 by 2 matrix. If they are the same, you can add or subtract them. And to add them, all I would do is A plus W. Add those 2 elements up. That gives me the E11 element. It's called the E11. Then I would do B plus X. That gives me the E12. So remember, this is called E11, E12. What does E11 mean? First row, first column. First row, second column. Next one would be C plus Y. I should have made that bigger. And the last one would be D plus C. This is called the E21 element. This is the E22. E21, second row, first column. E22, second row, second column. So here, let's go ahead and try this. I have 4 matrices, right? The first thing I'm going to do for each matrix is identify its dimensions. Matrix A, what are the dimensions of matrix A? A is a 2 by 3, 2 rows by 3 columns. B is a 3 by 2, 3 rows, 2 columns. C is a 3 by 2, 3 rows, 2 columns. And D is a 2 by 3. So anytime you start doing operations on matrices, you should always identify what your dimensions are. Now that I know what dimensions are, next thing are, oh, I didn't see that. 2 by 3, 3 by 2, my fault, 3 by 2, 2 by 3. So it says perform the requested operation. The first one says to add A plus D. Question, can I add A plus D? Yes or no? Yes. Why can I add A plus D? They have the same dimensions, right? So all I have to do is add each element to this corresponding element. So here I'm going to add -1 to +4. What's -1 plus 4? 3. Let me write that out so we know what I'm doing. -1 plus 4. There. Next I'm going to do is 5 plus, in this case, 5 minus 2. Then I'm going to do 0 minus 1. Then I'm going to do 3 minus 4. And I'm going to do -3 plus 3. And I'm going to do 2 plus 1. And I wrote all that out. You don't have to write that out like I did. I just wanted to make sure you knew where I was coming with it, where I got them from. So that's every element adding to its corresponding element. I'll write the answer over here. Here's what you're going to get. I get the new matrix is +3, +3, -1, -1, 0, and 3. Here's that new matrix. And that's how I got it. Y'all do B minus C, please. Do B minus C. First question is B minus C. Can you do B minus C? Yes or no? Yes. So do B minus C. Hey, you can handle the negatives one of two ways. You can go through and do what I did, which is actually subtract them and flip signs while you're subtracting. Or an easier way is negative really just means when they say minus C, right? All they're really telling you to do, a minus C is really telling you to do what to your signs. Flip all your signs. So you could have did minus C as -3, +3, 0, +2, -1, and then +2. And instead of subtracting, you could have just added B and C now. I got that? Whichever way works for you is fine. So just know that when you see a minus, minus just means flip all the signs in the matrix. So you can flip all the signs and add, or you can actually just work it out like I did right there too. But you should have gotten 0 minus 3, -1 plus 3, 4 minus 0, 1 plus 2, 3 minus 1, and -2 plus 2. So that adds up. I get a matrix of -3, 2, 4, 3, 2, 0 in the rows, right? All right, so the next one says C minus B. Can I do C minus B? Yes, C minus B is possible, right? If you can't do it, we say it's not defined. All right, it's called not defined, but C minus B is doable. And again, on this one, I would go through and change B into its opposite matrix. So I would do 0, 1, 4, sorry, -4, -1, and -3 and +2. And I would just add the matrices. That's because I like adding though. So when I do this, I get 3, 1 minus 3, -2, 0 minus 4, -4, -2 minus 1, -3, 1 minus 3, -2, and then -2 plus 2 is 0. But again, if you want to do it the other way, you can too. And that one you would do 3 minus 0 is 3. -2 minus a -1, so that's -2 plus 1, right? I didn't do that right, did I? Oh, that's -3. I thought it was a -2. -3 plus 1 is a -2. That's how I got it up here. Then it's 0 minus 4, -4, -2 minus 1, -3, 1 minus 3, -2, and then -2 minus 0. -2 minus a -2 is -2 plus 2, gives you a 0. Last one, D plus A. D plus A is going to be 4 minus 1 is 3. -2 plus 5 is 3. 1 plus 0, 1. -4 plus 3, -1. 3 minus 3, 0. And then 1 plus 2 is 3. Hey, this demonstrates a valuable point, by the way, too. Notice that D plus A is 3, 3, 1, -1, 0, 3. A plus D was also what? 3, 3, -1, -1, 0, 3. Do y'all see that? Exact same matrices. We see? Exact same matrices. Except the order was flipped in the way you added them. Just like in real math, if I add 2 plus 5, that's the same thing as 5 plus 2. What do we call it? Anybody know what it's called? When you can change the order of something and still get the same answer. Anybody know what property that is? It's called the commutative property. For the addition of matrices, the commutative property holds. So you can add matrices in any order and get the exact same answer, right? But look what we did here. When we did B minus C versus C minus B, do we get the same answers? No, we didn't. There were different answers, right? And that's just like saying 5 minus 2 is different than 2 minus 5, right? Subtraction, the commutative property doesn't hold. Everybody understand that? So we can add matrices in any order, but we have to subtract in a specific order. All right, matrix equations. Find the values of A, B, C, D to make the matrix equation true. So look here. I give you matrix. You give you a matrix of elements A, B, C, and D. I'm telling you it's minus that, and it has to equal those numbers on the end. Everybody got that? So these are called matrix equations. And here's what happens. To set up a matrix equation, I know that when I do A minus 2, what does it have to equal? 4. A minus 2 has to equal 4. Y'all see that? A minus 2 has to equal 4, right? I know that when I do B, look, B minus a minus 2 actually means that's B what? Plus 2. That has to equal what? I know when I do C minus a minus 1, so that's C plus 1, that has to equal what? Negative 3. And I know when I do D minus 4, that has to equal what? These are called matrix equations, all right? All I have to do is go solve for each variable now, all right? So I want to solve A minus 2 is equal to 4. What does A equal? How do I solve that? Add 2 to both sides. What does A equal? A equals 6. How do I solve B? Subtract 2 on both sides. B equals what? 1. C, subtract 1 on both sides. C is equal to a negative 4. D, add 4 to both sides. D is equal to 6. So the original matrix should have been 6, 1, negative 4, and 6. You can verify it by going back and doing it again now. So if I do this, what is 6 minus, the first one is 6 minus 2, that equals 4. 1 minus a minus 2 is a positive 3. Negative 4 minus a negative 1, so that's negative 4 minus, that'll be negative 4 plus 1, negative 3. And then 6 minus 4 is equal to a positive 2. Y'all try the next one, please. Try B. We have A plus 1 has to equal 2. B minus 3 has to equal 0. C minus 1 has to equal negative 1. And D plus 2 has to equal positive 1. So again, just solve equations. Minus 1 here, minus 1 here. Looks like A is equal to 1. Plus 3 here, plus 3 here. B is equal to 3. Plus 1 here, plus 1 here. C is equal to 0. And plus 2 here and plus 2 here. D is equal to 3. So final matrix I get is 1, 3, 0, and 3. You okay with that part? No. What I do wrong? Oh, my fault. Y'all right. Good catch, man. Minus 2. So it should be negative 1, right? Y'all feel better now? Good job. Minus 2, so I get negative 1. We're okay with that, though, right? So we understand the process? We're going to use this again in a second. Matrix C was... Let me grab them. Copy. All right. So we just talked about this. Notice that an important property of matrix is shown here. Matrix addition is commutative. Matrix addition is commutative. This means that the order does not matter. Matrix subtraction is not commutative. Next thing, the associative property. Because the order in which adding matrices, I was about to say, what is that supposed to mean? Adding matrices does not matter. If we add more than 2 matrices together, we can group that order of addition differently and get the same results. What that means is this. If I take matrix A and add it to matrix B, right? A plus B plus C is equal to A plus B plus C, like this. What does that say? What is this saying? I can add matrix A and B together first, and then add C to it. That's the same thing as adding what first? B and C together, and then adding A. That's what the associative property says, all right? Doesn't matter the order we add in. A zero matrix. A zero matrix is a matrix in which every element is zero. So, for instance, let me give an example. Here is a zero matrix for a 2 by 3. This is a zero matrix for a 2 by 3. Literally every element is zero. You got that? That's all it is. Zero matrix. Every element is zero. Scalar multiplication. A scalar is a constant that is multiplied. That is multiplied by every element in a matrix. So I want you to do negative 5c, but I did not tell you what negative 5c was. I gotta go back and get it. Hold on. All right. Paste. All right, here. This is the matrix we need. There we go. If I want to do negative 5c, scalar just means you multiply every element by that number in the matrix, right? So negative 5c is equal to what's negative 5 times 3? What's negative 3 times, what's negative 5 times the negative 3? Positive 15, right? Negative 5 times 0, negative 5 times the negative 2, positive 10, negative 5 times 1, and then negative 5 times the negative 2. Here's the scalar for negative 5c. You got that? If I want to do 3D, 3D is the other matrix I asked you to do. What am I going to do? Multiply every element by what number? 3. So 3 times 4 is 12. 3 times negative 2, negative 6. 3 times negative 1, negative 3. 3 times negative 4, negative 12. 3 times 3, 9. And 3 times 1 is 3. These are what we call scalars. Everybody okay with a scalar, right? So let's apply a real life example to this. I don't want to do that. This says, Miss Smith and Mr. Jones are salespeople in a new car agency that sells only 2 models. August was the last month for this year's model, and next year's models were introduced in September. Gross dollar sales for each month are given in the following matrices. So here is the August sales, right? Here are the 2 models that they have, by the way. They have a compact and a luxury. Everybody see that? Compact, Miss Smith sold 45,000. Mr. Jones sold 106,000. Luxury models, though, Miss Smith sold 77,000. Mr. Jones sold 22,000, right? First off, real life, what does this really mean? Somebody help me out what this means real life. Is Miss Smith or Mr. Jones a better salesman? What do you think? I'm asking y'all for real. What do you think? It's like real world, by the way. Look what they're saying. Who's a better salesman? Hard to tell, right? But we can tell that they sell to 2 different types of people, by the way. This Mrs. Smith sells more to who? High end or low end? High end. Look at her luxury sales. Y'all see that? They're a lot higher than Mr. Jones's luxury sales. Mr. Jones sells to more, I don't want to say low end people, but like more common people. You know, you go to get like, I don't want to talk about nobody's car, but you go to get a Nissan or something. It's not a knock when you got a Nissan. I got a Nissan. So I'm buying from Mr. Jones more than I'm buying from Miss Smith, what I'm saying, all right? So that's all I was just saying. September sales, look at the September sales though. They jumped significantly. Do y'all see that? But they still tell me that Mr. Jones is selling more compacts and Mrs. Smith is selling more luxury. This is how we really use real life matrices. You see that? I have these 2 variables, compact and luxury. for these two people, Miss Smith and Mrs. Jones, and I'm organizing like this in this matrix array. So what were the combined dollar sales in August and September for each salesperson and each model? How would I find that? What I'm asking you to find. If I want the combined dollar sales, what I'm asking you to find. I'm asking you to add them up, right? I'm asking you to add them up. So I want to add up matrix A plus B. Matrix A plus B. That's what I'm asking you to find. So I'm going to add these up. I'm going to add up Mrs. Smith's compact sales. What was her compact sales? Yeah, for both of them. You add the combined. 45 plus 190. So $235,000. So her entire compact sales for the months of August and September was $235. How did I get that? I added up this element to this element right here, corresponding elements. I got that. Next one, what was her luxury sales? 77 plus 345. This is $422,000. What was Mr. Jones's sales? 6 plus, for his compact sales, it was 372,000. For his luxury sales, I got two. There you go. That's all it is, adding those up, right? What was the increase in dollar sales from August to September? How would I find that? Subtract them. So this is just, which one do I do first? I want to know the increase from August to September, right? How would I do that? A minus B or B minus A? B minus A. I'm not going to do that, but that's what I'm asking you to find. Y'all got that? I'm asking you to find B minus A there. Because that'll give you the difference between the two. That'll tell you what you're increasing by. I guess we can do it since I've already done it. So in Mrs. Smith was 190 minus 45, so that is 140. So she had 145,000 increase, right, from August to September in terms of her compact sales. And then it was 345 minus 77, 268,000 increase here. 266 minus 106, that's a 160,000 increase. And then from 276 minus 22, that is a $254,000 increase. Hey, you could have did A minus B. All your answers would have been what, though? If you did the A minus B, what would have happened? You would have got what kind of answers? Negative answers, which means that still B was a higher month for both of them, right? Last one says, find the sales, if both salespeople receive 5% commissions on gross dollar sales. Gross dollar sales means the ones that their combined sales. From this matrix right here, you calculate it right here, right? So they each receive 5% commission. Compute the commission for each person for each model sold in September. So what I'm asking you to do there, let's call this new matrix that we created right here, let's call it matrix C, by the way. Let's call that C. So I want to do 0.05 times C. 0.05 stands for what? The 5% raise they get. And it's just a scalar. So 0.05 times 235,000. That's a nice commission check. Shit. If I got a commission check like that, I wouldn't have to work Saturday mornings. Look at that, man. That's 11,000. That's almost. But I guess that's how they get paid, though, right? They get I don't know. I've never sold cars. Any of you ever sold cars before? They get a base salary. They get a base salary. I don't think they do. Or they just get straight commission. Yeah. They got it. They got to get a base, right? Some places do it. I think some places don't. You gotta get a base plus commission. I mean, that'd be nice because you're right. I see why they try to get me when I walk in there. They try to get me to buy something. As soon as I walk in, I just want to look. Nah, we ain't gonna let you look. Yeah, you gonna walk out with a Nissan. You gonna walk out with this Nissan today. 298 times You see what I'm doing, right? Just multiplying everything by 0.05. That's how I'm getting these numbers. So here they're commission cells. We okay with that? Who's at 98,000? God. Anything else on this one? Yes, there is. Okay. Multiplication. Let's talk about this last thing, and we'll stop there. Matrix multiplication multiplies the, and here's how we multiply matrices. So matrix multiplication is not the same thing as scalar multiplication, all right? Scalar multiplication is taking a number and multiplying it by every element. Matrix multiplication it multiplies the rows of one matrix by the columns of another. You have to multiply rows by columns, and you add those elements up. In order to multiply matrices, the inner dimensions of the matrix must match. The new dimensions of the multiplied matrix are the outside dimensions or the outer dimensions. Here's what I mean by that. The first thing you do in any matrix multiplication problem is you always want to know, can you actually do it? So again, find the product of each multiplication if possible. Each matrix multiplication if possible. First thing we're going to do, identify the dimensions. So we have A is a 2 rows by 3 columns. B is a 3 rows by 2 columns. C is a 3 rows by 2 columns, and D is a 2 row by 3 columns. I want to multiply A by C. A by C. The first thing I do, write out the dimensions. So A is a 2 by 3, and C is a 3 by 2. I'm sorry, it is a 3 by 2. A 3 by 2. Got that? First thing I'm gonna do is look at the inner dimensions. I'm looking at the inner products, or the inner dimensions, which are these two right here. Do they match? Do they match? Do the inner dimensions match? Are they both 3s? Yes. So since they both match, we can do this multiplication here. The new matrix that we're going to create is going to take on the outside dimension. So a 2 by 3 by 3 by 2 is going to give me a 2 by 2 matrix when I complete this. A 2 by 3 by 3 by 2 gives me a 2 by 2 in the end. Here's how this works. Matrix A, -1, 5, 0, 3, -3, 2. Matrix C, 3, -3, 0, -2, 1, -2. Multiply a row by a column. Row by column. Everybody got that? So watch what happens when I do this. Here's I get a 2 by 2 out of this. Take this element right here. First row, right? First column. It's -1 times 3. I'm going to multiply -1 times 3. What's -1 times 3? -3. So first element is -3. Got that? Row by column. What's 5 times 0? Plus 0. What's 0 times 1? 0. Come on, right. Plus 0. That's how you calculate the first element in this thing. First row, first column. Got that? I like to write this above it so I know what I'm doing. First row, first column. Next row would be E1, 2. So what does that say multiplied by? First row, second column. So again, now I'm going to do what? -1, but this time I'm going to multiply by what number? What's in the second column? -3. What's -1 times a -3? +3. What's 5 times a -2? -10. What's 0 times a -2? Next I'm going to focus on is the E21. What does that say multiply now? E21. That says multiply the second row by the first column. Second row, first column. What's 3 times 3? 9. What's negative 3 times 0? 0. And then what's 2 times 1? 2. The last one says do the E22. What does E22 mean? Second row, second column. 3 times negative 3. Negative 9. Negative 3 times a negative 2. And then 2 times a negative 2. Negative 4. So this is going to produce my 2 by 2 matrix. I got that? It's producing my 2 by 2 matrix. So when I add these up, this is equal to final matrix, negative 3. It looks like negative 7, positive 11, and 7, negative 7. Yeah. Negative 9. Yeah, negative 7. There. Negative 3, negative 7, 11, negative 7. Matrix multiplication can be confusing, to say the least. Look at the next one, B times D. Y'all give that one a shot. B times D. First off, can I do B times D? Yes or no? Figure out if you can do B times D. If you can, then go ahead and do it. Right? First row, first column. So I want to do 0 times 4. What's that? 0. And then negative 1 times the negative 4 is a positive 4, right? Got that? Next thing, first row, it should be a 3 by 3. Let me make this bigger. Next row will be first row. First row, second column. First row, second column. 0 times negative 2, 0. Negative 1 times 3, negative 3. Last one, first row, third column. 0 times negative 1, 0. Negative 1 times a positive 1 is a negative 1. And when you multiply matrices, the best thing you can see in the matrix is a 0. When you start seeing zeros, it makes a lot of the matrix simplify very easily. Next one, second row, second column. Second row, first column. So second row, first column. 4 times 4, 16. 1 times 4, negative 4. Second row, second column. 4 times negative 2, negative 8. 1 times 3, positive 3. Second row, third column. Second row, third column. 4 times a negative 1, negative 4, and 1 times 1, positive 1. Last row. Third row, first column. 3 times 4, 12. Negative 2 times a negative 4, positive 8. Third row, second column. Third row, second column. 3 times negative 2, negative 6. Negative 2 times 3, negative 6. Right? Yeah. Third row, third column. Third row, third column. 3 times a negative 1 is a negative 3. Negative 2 times 1 is a negative 2. So this matrix cleans up to be 4, negative 3, negative 1, 12, negative 5, negative 3, 20, negative 12, negative 5. That's my matrix in the end. All right, one more. Let's do A times D real quick. A is a 2 by 3. And D is a 2 by 3 also. First thing I'm going to do the inner dimensions match. No, they don't. So this is what we call not defined. It's not defined.